1994 essay question. So here you can see in this diagram I have marked the currents I1, I2 and I1 plus I2 currents, and I have also marked points A, B, C, D, E, F, so I can apply Kirchhoff's rules. So here you can see I have applied sigma is equal to sigma ER, Kirchhoff's second rule, to ABCFA loop. From that I get equation number 1, and then I apply sigma is equal to sigma ER to ABCDEFA loop. From this I get the second equation. So simultaneously you can solve the two equations and you can find out the value for I1 as well as value for I2. Here for I1 I get 26 over 15. For I2 I get minus 2 by 15. So I2 direction has to change. You can see that I have now found voltmeter and ammeter readings. In order to find the voltmeter reading, voltmeter reading is the potential difference between E and D. So I have drawn the E and D part separately here. So I can consider these two, the battery and the resistance, as a single cell with an internal resistance. So we have a single battery, we can consider that we have a single battery with an internal resistance and current drawing into the battery. So when the current is drawing into the battery, the equation that we can apply in order to find the terminal potential difference is P equals to E plus IR. So I have applied that and I get 6.27 volts. Also they are asking the ammeter reading. Ammeter reading is the current which is passing through the ammeter, which is I1 plus I2. Since we have got a minus value for I2, we have to apply as it is. So when you apply, I have applied this in fractions because maybe it is getting simplified and we are going to get a good answer when you do the fraction. So I got 1.6 amperes as the current passing through the ammeter. Here now they are asking us to find out the total heat dissipated, the energy supplied by the 12 volt battery in first 2 seconds. So in order to find the energy supplied by the battery, the equation that we are going to apply is W equals VIT. So I applied the equation W equals VIT for the 12 volt battery here. So when I apply that, I get 41.6 joules for the energy dissipated or the energy given by the 12 volt battery in 2 seconds. Right. So then they also ask in part C the total heat dissipated in the circuit in 2-second duration, in the same duration. What is the total heat dissipated in the circuit? So in order to find out what is the total heat dissipated, we have to consider the resistances: 1 ohm here, 2 ohm here, 2.5, 0.5, 2 and 4. So we have to apply the equation P equals I squared R, and we have to multiply that by T. Similarly, you can say that it's you're applying W equals I squared RT. This is that equation, W equals I squared RT. So you're applying that equation to each and every resistance in the circuit in order to find out what is the total heat dissipation. So I have applied that to this loop first. Here 2 ohm and 1 ohm, it's 3. That into I squared into 2 seconds, and then I have applied it to I1 plus I2 squared into 0.5 plus 2.5, that is also 3. That's this part. And again to the last one here, the 6 ohm here for that. So when I do that, finally I get 33.5 joules. And now they ask why there is a difference in the answers in part B1, 1B and 1C. There's a difference. What's the difference here? The difference is that for the 1D part you got 41.6, and but the total heat dissipation is 33.5. So there is an energy loss that we don't see here, and let's wonder why there is an energy difference. The energy difference is because now you can see that I1 plus I2 value, that is 1.6. So 1.6 ampere current is going into this 2-volt cell, so it's getting charged. And also this I2 is a minus current, so it's charging the 6-volt battery as well. So these currents given by the 12-volt battery is now charging the 2-volt battery and the 6-volt battery. මේ 2-volt battery එකයි 6-volt battery එකයි charge කරන්න මේ 12-volt එක පාවිච්චි වෙනවා. ඒතකොට එතන තව energy ප්‍රමාණයක් ඒකටත් පාවිච්චි වෙනවා. So some more energy is being used to charge 2 volts and 6 volts batteries. So that is the reason why there is a difference in energy, because energy is being used to charge 2 volt and 6 volt batteries. So we can write that here. Energy given by 12 volt cell is used to charge 6 volt and 2 volt cells. What they have asked us in the third part is to find out the voltmeter and ammeter readings when they are interchanged. Now voltmeter and ammeter are being interchanged. So you know, when you interchange or when you replace the ammeter with the voltmeter of infinite resistance, there will be no current passing through this particular part of the circuit. No current is passing. Right. So therefore, there will be another loop added, because now there's an ammeter connected here, so there's another loop added. So still we have three currents. I have marked the three currents, I1, I2 and I1 plus I2. So again we can apply Kirchhoff's rules. Right, so I have applied Kirchhoff's second rule to ABCDEFGHA loop, so I can get this relationship for current. Then I have applied the same for ABCDGHA loop, so that again I get another equation for I1 and I2. Then I have simultaneously solved it to find out the I1 and I2 values. Here are the I1 and I2 values. So when I get I1 and I2 values, I know that the ammeter reading is I1 plus I2. So I'm going to just add them. So once I add them, I get 3.57 as the overall ammeter reading. And they also ask us to find what is the voltmeter reading now. And you know, there is no current passing through this path, right? So there is no potential difference in this resistor. So I'm going to draw that part separately. I'm going to draw that part of the circuit separately here. Right, and I can also mark the current, the I1 current, that is 1.46. Battery is 12 volt and this is 1 ohm. 2 volt battery is here, and there's a 2.5 ohm resistor which actually we don't need, and here we have 2 ohms. Right, so what I'm going to do now is I'm going to find out the potential at one point considering the other point as 0. Right, so I'm going to take this point as 0 The reason I'm going to take that point as 0 because it doesn't do any difference, because we want to find the potential difference. So if I take this point as 0, if I take this point as 0, which is not actually, epsilon method 0 नहीं value है, but I take that as 0. So here will be minus 2 because we are going from plus terminal to minus terminal, and there's no current passing through 2.5, so there is no potential difference. Here also it's minus 2. Therefore here also it's minus 2 because we are going through a wire with zero resistance, and at this point we can say there is a potential drop. A potential drops by 1.46. So minus 2 minus 1.46 is minus 3.46. It's minus 3.46. And again we go from minus terminal to plus terminal through a battery. So what we get is that minus 3.46 plus 12. So minus 3.46 plus 12, let's see how much that value is. That is 8.54. Here we have 8.54. Again, when you go through this resistor, another drop we have, an IR drop, and that drop is 1.46 into 2. So that is 2.92. So the potential again reduces by 2.92. So 8.54 minus 2.92, that is 5.62. So now we can say the difference between the terminals of this voltmeter is 5.62 volts. So therefore we can say the voltmeter reading is 5.62 volts. 5.62 volts. That is how you get the answer here.